So very good morning students. In this video, I am going to explain the another topic of manufacturing process of the monolithic IC. That means IC fabrications. So the monolithic circuits means the circuit fabricated from the single stone or single crystal. So the mono meaning the single and litho meaning stone. So the monolithic IC are in fact the made in single piece of single crystal silicon. So the fabrication of the discrete devices such as transistor and diode and IC in general can be done by the same technology. So the various manufacturing process by which IC is fabricated usually take place through the single plane. The technology also referred as a planar technology. So the basic process involved in the fabricating the monolithic IC. So the basic process the use of the fabricating ICs using silicon planar technology can be categorized as follows. First one is the silicon wafer preparation, second one is the epitaxial growth, then oxidation, then photolithography, then diffusion, then ion implantation and isolation technique and metallization. Final one is the assembly, packaging and processing. So we will discuss in detail about the silicon wafer. The silicon wafer is nothing but a substrate preparation. So the following steps are used in the preparations of silicon wafer. So crystal growth and doping, and in-code trimming and grinding, the in-code slicing and wafer polishing and etching and wafer cleaning. Okay, next one is the epitaxial growth. So epitaxial growth means the epitaxial meanings arranged upon is a process of the depositing thin layer, so 0.5 to 20 microns of single crystal material over the single crystal substrate. So we can describe the epitaxy of arranging atoms in single crystal fashion upon the single crystal substrate, so that the resulting layer is extension of the substrate and crystal structure. So the basic chemical reaction used for the epitaxial growth for pure silicon is a hydrogen reduction of silicon tetrachloride. That means SiCl4 plus 2H2 equal to, then is divided into the Si, the components is decomposed into the two types and 4HCl. So the mostly the epitaxial films or specific impurity concentration are required. So this is accomplished by the introducing phosphoine for the N-type and bifluorine for P-type doping into the Si tetrachloride hydrogen as stream. So that the process is carried out in the reaction chamber consisting of the long cylindrical quartz tube encircled by the RF index coil. So next important process is oxidation. So oxidation, so SiO2 is a property of preventing diffusion of almost impurities through it. It serves a two important purpose. So SiO2 is an extremely hard protective coating, is unaffected by the almost all regions and except hydrofluoric acids. So thus it stands against any contamination. So by selective etching silicon dioxide, the diffusion of impurities through the carefully defined windows in the SiO2 can be accomplished to the fabricate various components. So by selective etching of SiO2, the diffusion of impurities through the carefully defined windows in the SiO2 can be accomplished to fabricate various components. So the silicon wafers are stacked up in the quartz boards, then inserted into the quartz furnace. The silicon wafers were raised to the high temperature of a range of 950 to 1150 degrees Celsius. At the same time, exposed to the gas containing O2 or H2O or both, the chemical reaction is that silicon is reacted with water and produces silicon dioxide, and the hydrogen gases will give away. The oxidation process is called as a thermal oxidation because of high temperature used to grow the oxide layer. So this is a chemical reaction that is used for the oxidation process. So the silicon wafers are raised to the high temperature in the range of 950 to 150 degrees Celsius. At the same time, exposed to the gas containing O2 or H2O. This is the following chemical reaction. This is a process of producing the silicon dioxide. Photolithography. So photolithography, with the help of this process, it has become possible to produce microscopically the small circuit and devices patterns on silicon wafers. The two processes generally involved in the photolithography is the making of photolithographic marks and photo etching. So the making of photolithographic marks involves the following sequence of operation is the preparation of initial artwork and reduction. So what is the preparation of initial artwork means? The initial layout artwork is normally done at scale and several hundreds of times larger than the final dimension of the finished monolithic circuit. The artwork usually produced in the precision drafting machine known as the coordinate craft. Next one is the reduction. The Ruby's pattern of individual marks is photographed and then reduced in steps by a factor of 5 to 10 several times finally up to the exact same size. The photographic mask. The development of photographic mask involves the preparation of initial artwork and diffusion and reduction and decomposition of initial artwork layout to several mask layers. Next one is the photo etching process. What is the photo etching? Photo etching used for the removal of SiO2 layer from the desired region so that the desired impurities can be diffused. What is the diffusion? The most important process in the fabrication is the diffusion. The process of introducing impurities in certain region of silicon wafer is called as the diffusion. The rate at which the various impurities diffuse in the silicon will be the order of the 1 micrometer hour at the temperature of 900 degrees Celsius to 1000 Celsius. The impurity atoms have the tendency to move from regions of higher concentration to lower concentration. First one is ion implementation technique. Generally the diffusion has a two important processes, ion implementation and isolation techniques. So it is performed at low temperature. Therefore, the previously diffused regions have a lesser tendency for lateral spreading. So in diffusion process, the temperature has to be controlled over the large area inside the oven. So whereas in ion implementation process, accelerating potential and beam content are dielectrically controlled from the outside. So next one is the process of diffusion. So dielectric isolation. So the dielectric isolation layer of solid dielectric such as SiO2 and Ruby completely surrounds each component. So thereby producing the isolation. So both electrical and physical isolation. This isolating dielectric layer is thick enough so that its associated capacitance is negligible. So it is possible to fabricate both PNP and NPN transistor with same silicon substrate. So this is having two types of isolation, PN junction isolation and dielectric isolation. So advantages of the dielectric isolation is a superior performance and slightly expensive. These techniques mostly using the fabricating the professional grade ICs required for the special applications like aerospace grade and military grade. Last one is the metallization. So metallization is to produce the thin metal film layer that will make interconnection of various components of the chip. So the aluminum is mostly used for because of following disadvantages. It is a relatively good conductor. It's easy to deposit aluminum films using the vacuum deposition. It makes good mechanical bonds and silicon. So aluminum forms a low resistance and ohmic contact with p-type silicon and heavily doped n-type silicon. So this is the following reasons for that's why aluminum preferred for the metallization. It's a good conductor, easy to deposit. It's a good mechanical bonds. It forms a low resistance contact. So what are the IC packages available in the electronic field? The IC field means metal can package and then dual inlet package and ceramic flat package. Okay. So last one is assembly packaging and processing. So the the metal can package can available at 8 to 10, 12 leads. So whereas the flat dual packages commonly available 8 to 14, 16 leads. But even 24, 36, 40 leads are also available for special circuit. Ceramic packages are whether a flat type dual package or costly due to the fabrication process. So have advantages of best hermetic sealing. Most of the general purpose ICs are dual inlay plastic patches due to the economically. So these are the things we have discussed of the fabrication process involved in the manufacturing of the monolithic IC. So that's it about the fabrication of IC. Thank you.